Okay. Hello, everyone. Mic check. I think we can start. Yes, all good. Hi, everyone. We're very excited to welcome you all to this in this AMA with CEO of CUDO and CUDOS, Matt Hawkins. Hi, Matt.
Good to see you. Hey, Luke.
Good to see you. Long time since we had one before.
Yeah, been very busy.
Yes, I can see that. Thank you all for tuning in. And in this stream, we're going to talk about the latest on what's happening with CUDO, with CUDOS, and me and Matt, we're going to have a discussion about the latest progress in building the technology and also for the Super Intelligence Alliance. How are you doing, Matt, today?
Yeah, good, thanks.
Yeah?
Yep.
What have you been up to recently?
So you'd have seen in the market, obviously, news is everywhere about the AI compute and the increase in AI compute. You're seeing that from NVIDIA's share price that we work very closely with. You're seeing that from the demand in the different AI platforms. And it's all about scale. So that's what's changed. I think initially it was purely about innovation and getting it out into the market. Now what's happening is the service providers and the buyers out there are buying at mass scale. So it used to be that you could do training on small amounts of compute. You could build a model, so if you wanted to build a foundational model, which is like a ChatGPT or a Gemini, it's where they've built the core AI themselves, then you could do that in small amounts of compute. Now they need massive amounts of compute. So if you look at ones like xAI, for example, they're doing a 200,000 GPU deployment.
Or for the XS.
Yeah, for the next version that's coming out. So got 5.
The Grox infrastructure. Okay.
Yeah, and then they're adding to that as well. So it's things at scale. So what we've done is, as a platform and a business, is we focused on enabling the scale. Mm-hmm. Whereas initially we focused on enabling access to individual GPUs. Now we focused on enabling access to and managing thousands of GPUs. And that's where the shift has been. So that's kind of a shift that we've been doing over the last 12 months or so.
Fascinating.
It's really focusing on enabling the technology for the bigger clients to use our software stack to run and operate those clusters. And then also enabling that stack to be able to support selling it into the market so that service providers that are buying the capacity can then sell it to the larger clients that we work with. You
mentioned clusters. Maybe it would be worth to explain to the audience what GPU clusters mean. Like, how do you see the clusters and what those are?
Yes, so an AI server has 8 GPUs in it, and they're mostly NVIDIA. About 90% of the market is NVIDIA, and that has a certain amount of memory in it, which is fine if you've got 2 types of computing. You've got inference and you've got training. Inference is when training, actually, if you start at the beginning. Training is when you talk to or you build the brain. So you're kind of building the intelligence, and then inference is when you're talking to the intelligence.
Yeah, the thinking part, almost like processing the models that you run.
So inference can run more easily across multiple locations. Mm-hmm. Training needs to be done in a single location, or you make that location as big as possible, and sometimes you have to cut it up into chunks just because of the capacity isn't available in single locations. So these are tens or hundreds of megawatts at a time, which is the size of entire cities of power that's used.
Wow, that's huge.
And that's when it's a cluster. It's a cluster of GPUs together
to do parallel processing.
Used to do, that are all trained at once, and they're interconnected with massive amounts of network connectivity so that they communicate really fastly with each other. And that enables you to treat it as if it's one giant computer. That's essentially what you're trying to do.
That's very interesting, because I heard that from someone that we should be thinking of those big AI factories or clusters as one computer rather than multiple GPUs, because they're always interconnected to do training, interconnected to the inference. So when you say the cluster is like 1,000 GPUs, I think before we started, you mentioned 1,000 GPUs is usually a cluster. The mental model for this is, it's not just 1,000 individual GPUs. They all work in tandem, parallel to provide this compute for a workload, for example.
Yeah.
Would you agree with that?
Yes. 1,000 is kind of where we see a lot of people starting.
Okay.
GPUs.
And that's what CUDOS is providing a lot.
Yeah. Okay. We're providing ones where it's in the hundreds of GPUs or in the thousands of GPUs.
Yeah.
And we're directly working on deals at the moment in the tens of thousands of GPUs. And that's because we've changed our technology stack. We've changed the types of partners that we're working with so that we can work on these much bigger solutions.
Okay.
But the way it'll work is one of two ways. Either that cluster is assigned to one customer and they're purely using it for all their own training, and that's called private cloud. It's dedicated infrastructure.
So my AI factory, just for myself, nobody else can use that compute. It's just for my use case as an enterprise.
Yeah, exactly. So if we took, let's say Mistral, which is a foundational model provider.
We've got that on ASI Cloud as well. Yeah, so.
Yes. Yes. So they have a 16,000 GPU cluster in France, for example.
Okay.
And that is just one giant cluster. We'll be using somewhere between 20 to 30 megawatts of power, which is a huge amount of power. To give you an idea, your average household uses like 2 to 3 kilowatts.
Yeah.
So it's thousands of homes worth of power, or tens of thousands of homes worth of power. And yeah, that will be treated to one client. But what we've also been doing is building the technology to multi-tenant that environment so that it can be split up and turned into lots of customers underneath. Right. So we work with telecoms providers, for example, which are like the communications companies. And often they want to be able to split that up into lots of different clients beneath them.
So they resell that compute to someone else or offer it to their clients.
Yeah. So they will have thousands of clients, and they might have 10 clients that they want to split this cluster up into. And you have to make sure that the networking is secure, the servers themselves are secure, and then the fiber, the InfiniBand connectivity, which is the connectivity for the brain, if you think of it like that, that has to all be secure as well. So we've been building all of that. So InfiniBand, just for the audience who may not be aware, is that the networking technology, correct, for connecting the different GPUs? There's 2 types of networking in a cluster. There's Ethernet, which anyone in the IT space knows very well. The old school, which is is what your internet connection comes in on. Yeah. And then there's InfiniBand, which was designed for very fast connectivity, very low latency, which means very low speed to talk between 2 devices. So that's, you have the 2 parts. You have the bit that connects the GPUs together, and you have the bit that connects the servers together, if you think of it like that. That's true, because you can have the fastest GPUs on Earth, but if you don't know how to connect them correctly so they talk to each other very fast, and if the networking is slow, then there's an overhead, and your GPU's processing power, you either pay more money, correct? Because so networking is probably as important as the processing power, or maybe equally important. It's more important actually. Okay. If you try and train the bottleneck now, GPUs have become so advanced and so fast. The bottleneck now, when you're training, is always the networking. Okay. So you've got generations of GPUs that have come out. You had Hopper that came out a couple of years ago. You've got Blackwell that have just come out really this year in production. And that's come into 2 types of GPUs. I'm trying not to get too technical in this talk, but there was a B200 and there's a B300. Yes. So we're deploying those at the moment. And the B300 has doubles the network connectivity. So all of a sudden you've got a big leap in communications and speed of training again. And then you've got GB300s, which is kind of NVIDIA's top server at the moment. So it comes in at once, right? That's a whole rack. So a rack is like the size of a cupboard. It's about, depending on where you get it, somewhere between $4 to $5 million per server. Pretty decent price point. Pricing. And a lot of heat that comes out the back of it. Yeah. You have to cool it with liquid it's the only way to get that much heat out of the server quick enough. Liquid cooling, fascinating. You mentioned there's a big demand for clusters and GPUs, and before we talk more about the sort of CUDOS and the Web3, the ASI Cloud product we've been working on, it may be worth just describing where is that demand, where does the demand coming from? Like, where does it come from? Where is this need for bigger, faster GPU clusters based on your enterprise customers you've dealt with, or we at CUDO? What are you seeing in the market? Why is it so accelerating so fast? And just wanted to add, I had it somewhere, I think NVIDIA just reported their biggest earnings in the last quarter, which is significantly higher than last year. So that the speed and acceleration of the demand for AI compute is even higher, which means more clusters, more GPUs, more power. What's driving it? I mean, they're forecasting 500 billion worth of GPUs next year, NVIDIA. 500 billion? Yeah. Wow, okay. So it is increasing quite significantly, and we're working on a number of those deals as well, which we'll chat about later. So, you know, the reason is because if we go through, I would say the different types of models that are out there. You've had the ChatGPTs of 3, 4,
5.1 now.
Yeah, exactly. 5.1 was a generational leap. Then you've just had Gemini Pro 3 that's just come out.
Yeah, really good apparently. So
which
beats
is
all the benchmarks.
Incredible.
Yeah.
If you match that with ones like Nano Banana Pro, which is create the film and the animations and graphics, and their other development platforms that they've got, that's a real big generational leap. And this is the first time it's getting to the point really that you're getting to human level.
Okay, like self-improving intelligence.
A lot of hand-holding. The hand-holding is getting smaller and smaller. And then the same on Claude. So you've got Anthropic's Claude platform, which they've just come out with 4.5 Opus, which I also use. Incredible platform. Anyone that's used it already and that literally has only been out a few days, absolutely amazing. It's the first time that I've actually felt that it's the same level or better than a human. And that's the first time ever over the last few years that I think we're getting to that point. And then you've got Grok 5, which is going to be coming out in Q1. So it's a race between who can build the next biggest model, the next best model. Some will, like Claude, is really good at programming. Ones like Google are really good at like the video, the graphics, but also it's good at programming. Ones like ChatGPT are good generalist platforms. So they're kind of all going through their
Do they also consume
areas.
More compute? Do they need more compute?
Well, every time that you do the next model, you need to roughly double the amount of compute that you use each time. And that model release, if you look, the model releases are months, they're not years. So it's a constant competition. So they need more and more compute. And then, if you look at how AI works, we're now moving into, reasoning and thinking.
Slowly self-improving AI in a way.
Yeah.
That's what we get.
Yeah, and also, one of the amazing things on the Claude platform is like self-reflection. So it actually reflects its decisions.
I had that a few times. Sorry, I made a mistake. I actually corrected it now. And here's a new report, for example. I had that a few times.
Exactly. And then it goes, I'm such an idiot.
I've already presented that to my board and you corrected yourself.
Yeah, it's quite funny. So all of that takes more and more compute on the back end to work. So we're actually giving it more intelligence, more power, more memory.
Fascinating.
So it takes more processing power to build it, and it takes more processing power to run it afterwards. So that's why the constant demand is going there. And the race is over the next 2 years is to get to AGI where it's the same as humans.
They call it the AI explosion, which is the moment in time where one company gets to this level where it has this AGI or AGI-ish AI, and it may be so advanced that no one else can ever catch up.
Yeah.
Assuming that there's a very big distance between the sort of AGI AI and what the competitors have. Yeah. So there's this kind of race to who gets first, because who gets first wins the market in that regard, which is very fascinating. So before we talk about the CUDOS stuff as well, let's talk about data centers. So you've had obviously, and we at CUDO had this background of cloud computing infrastructure for 20 plus years. And you've been through this whole journey from the very beginning, right? When cloud computing came out in 2000, you were setting up those data centers, servers, rack spaces, and everything.
Yeah.
We have this evolution of data center into an AI factory right now, where AI workloads are predicted to comprise way bigger percentage of traditional workloads. So, storage and traditional workloads in data centers. And now we've got those AI factories. And you mentioned liquid cooling. I think would be worth, from your experience, to explain to the audience how that infrastructure changes, how AI factories are now built versus traditional cloud centers, and what it means to anyone operating or using the hardware. Just a few words about the AI factories versus traditional data centers.
So on our background, our background is running and operating and building data centers. So that comes in very helpful now. We operated, our last business, we operated space in about 50 data centers around the world. So massive experience and built data centers as well, and fiber networks and cloud platforms. So we've been doing this for far too long, since the early internet years. But everything over that period was air cooled. So you're using air to cool it, but air is very inefficient method of cooling. It's absolutely fine if you want to use it on your PC, or the simplest version is you use a hairdryer and use an air and heat to cool things, or it's the opposite actually. But it's transfer of heat from your hairdryer to your
just like computer fans are cooling, your CPUs and your traditional desktop machine, right?
Yeah,
the air cooling. Yeah.
Yes. So racks, which are the cupboard size things where we put the servers in, they used to exhaust 4 to 8 kilowatts of heat, which is the equivalent of 2 to 4 hairdryers, if you get an idea from a perspective. Technically, you can only cool somewhere between 40 to 60 kilowatts of heat in a rack using air. After that, you can't get enough airflow through that rack to
so there's a physical limit. Is that physical
limit?
Wow. Okay.
Limit on the speed of air that you would want to push through that machine. The servers already have a lot of air and fans inside them. And also, when you start to get up to 40 or 60 kilowatts, often the data center can't push enough air through. So you have big fans on the back of the rack, rear door heat exchangers. And that's used to exhaust heat, but you still hit your limit. And the newer servers, where we're working with NVIDIA on, like the Blackwells, you want to be, the minimum you really want to be doing in a rack is kind of 60 to 80 kilowatts. And that's where we're using the normal servers. The GB300s, which are the larger servers, they're doing about 140 kilowatts. You can't do that with air. So what you do is you actually have liquid connections into the back of the rack. So the rack actually has
physical pipes going through the rack.
So instead of blowing air through the room, you actually still use a mixture of air as well. But 75 to 80% of the cooling of the rack is actually done with liquid. So what you have is a liquid pipe system, which keeps clean water in between the servers. So it actually goes through into copper plates inside the servers, cools the chips down, goes back out as hot water.
So then you takes away the heat by out.
That's it. You send it outside, usually about 10 degrees hotter, exhaust into the environment or into a river or however you want to do it. There's different ways depending on where you are. Or you can do heat recovery, and you can put it into things like a heat exchanger, and then you can put it to things like district heating, and you can use it
turn into an energy
residential manufacturing,
heat a neighborhood,
anything that
for
needs
example.
heat, basically.
So there are some sustainable angles with liquid cooling for sure.
Okay, very.
That's great. It's more than just
if you can
spinning
match
air.
it up, it's actually massively efficient, because if you were doing district heating, for example, which heats lots of premises, you'd have to generate that heat. Typically, you burn gas because that's the cheapest way to do it. So you're getting rid of that, and you're using it from servers, which is an incredible way to do heating. But just going back to the heating or the cooling element, that's how you cool it down. So you exhaust the heat outside, and then you've got about 25-30% of the cooling is still air. We haven't yet for GPUs managed to 100% cool them with liquid yet. It's getting there. Over the next few years, you will see that. But at the moment, it's a mixture of both. But what that does is that reduces the number of data center locations that you can actually put.
Because you can physically put more.
Because
you can cool more.
Data centers over the last 25 years weren't designed to do liquid cooling. They didn't have enough power in the first place, and they used air for cooling. So this is a big change in how, so going back to your data center point, this is a big change in how data centers run. So all the new AI data centers have liquid cooling built into them. They're doing huge amounts of power. So somewhere between, the minimum is usually 10, 20 megawatts you'd have for a data center, up to hundreds of megawatts or sometimes a gigawatt, incredible amounts of power. And that's so that, the larger companies can go there. So we've partnered with energy companies and data center companies to deploy data centers. So this is to deploy energy data centers. So they're called like the AI factories, basically.
So that means what's CUDOS involvement in that? Designing architecture, infrastructure, or physical installation?
We will co-own the data centers.
Okay, sure. Okay.
So we own them together, and we're doing it with the energy companies that have got access to the energy, and that's powered by wind, solar, renewables.
That's great. Sustainable at heart.
And then also, we buy data center capacity from the companies in like Norway, Finland, Sweden, Iceland, those types of locations, which have much more efficient environments because it's colder environments. And then also it's also all renewable energy.
Fascinating.
And then we do that for, clients of ours that are now being installed, with the software stack. So it all becomes part of the network as well, to deploy these large clusters. So that's like the shift that we've been doing over, this
shift
year.
to clusters. Amazing. Seems like CUDOS has been very busy working with those bigger companies. I would see also as an NVIDIA cloud partner too, which is one of the very few in the UK that originally started.
Yeah,
so it's a great journey.
Jensen's keynote a few months back.
Oh yeah, amazing. Yeah, I've seen the pictures of our team.
Yeah,
amazing. So moving quickly to sort of the CUDOS side, which is the Web3 arm of CUDO, and recent launch of ASI Cloud, which obviously I had the pleasure to be part of, leading the product on CUDOS and ASI Cloud. Tell us a bit more about ASI Cloud, sort of the CUDOS side of things in the ASI Alliance, because I think a lot of the audience here are obviously from the Web3 space too, very interested to know how things are progressing with the products that we're building, and just your view where things going for the AI inference, for example, that we launched on ASI Cloud, and the traction that we're getting. It'd be good to get your views on that.
Yeah. Well, first, if I go back to that technology where we're building that multi-tenancy environment and we're bringing on clusters. So I think there was an announcement a few days ago from 𝗟𝗂𝗘, which the PR went online, which was, that's one of the first clusters that will be coming on to the network. So they will be a compute provider. It's over 1,000 GPUs, high performance GPUs. And that's because it's using our technology that we built for CUDOS, and that becomes available on ASI Cloud. So these are the first of the providers, big providers that are coming onto the network. So that gives huge amounts of computing that can be consumed directly from ASI Cloud. So right now, there's about 5,000 GPUs already sold on ASI Cloud that I think is putting us certainly in the top 3.
There's some more announcements next week coming from the GPU work that CUDO did with Singularity as well, which we'll unravel that next week more as well, about some more GPUs coming to cluster. And in fact, that actually relates to one of our questions, which was from Wizard King: will you host more models on ASI Cloud? Which yes, exactly what we're doing now is we're upgrading the cluster to have more models and host more models, more powerful models, big multi-billion parameter models to enable better quality inferencing as well.
Yeah, and to support those models at scale, we needed the computing.
Of course.
So you've been spearheading some of this side where it's building the inference platform and having it so that we can have these really good foundational models that are on there that need huge amounts of memory. Because as every model is getting better, they need more memory, which means you need more machines, or you need more modern servers.
So the more parameters there are, the more memory it requires to process. So one model, for example, DeepSeek 750 billion parameter, you need to put it on a number of GPUs depending on how much memory you've got, and the faster the hardware you get, the better the sort of model. But not all GPUs are the same. Some are better for inferencing, they're lower cost. Some are better for training as well. Generally, I think speaking of models and GPUs, what do you think is the state-of-the-art GPU right now for both model training and inference that you would recommend?
I mean, for doing both, it's definitely the Blackwell.
The Blackwells,
at the moment. Yeah, so it's the B200s and the B300s.
Yeah, definitely.
So those are both in production. Those are both rolling out into the market at the moment, and that's at normal scale. So if you're in the hundreds or a few thousand, it's the Blackwells, B200s, B300s. We're working on larger projects as well, which take longer to deploy and will be going live next year. But these are the GB300s, and they're in the tens of thousands of GPUs at a time. So so they're much bigger deals. So if you're doing it at scale, it's the Grace Blackwell, which is the GB300. And the reason is because it's just the huge amounts of servers and compute that is in a single server, and the ability to scale that much bigger. But for your general people and what ASI Cloud will use as well, will definitely be the B200s, B300s.
Yeah, that's great, because from the customer perspective, we've got different types of users. I think since we launched in September, we've got about 1,000 plus startups, developers, enterprises using the ASI Cloud inference platform specifically. There are obviously other customers using GPU Cloud, because let's not forget, ASI Cloud also has GPU rentals, so you can rent out L40S, H100, V100, different types of GPUs. which is basically using the same platform as the CUDO compute platform at the back end. And yeah, so we've got some AI labs using our infrastructure, some of really interesting open source AI projects for creating a tokenized set of tokens that can be used for model training. We've got some startups, so really various use cases, and it was really interesting to see the traction. And now, obviously, we launched this accelerator program. If you guys have not heard about this recently, we launched CUDOS and ASI Cloud, ASI in general, an accelerator program. So we're jointly doing that with 𝗟𝗓𝗓 to an ASI Alliance to bring more startups to our platform as well. So there'll be more about that soon. Good. Yeah. So I think in terms of what will be good to talk next is, I'm just looking at our little guide here. Yeah, so ASI Cloud as the AI compute layer for the ASI Alliance. How do you see this? You know about that ASI have just announced the ASI chain on DevNet, which is a great achievement by the team, and I'm also involved with some discussions with them. And we're going to be doing some really interesting stuff with ASI Chain 2 as ASI Cloud. Tell us a bit more about this play that CUDOS and ASI Cloud has within the ASI tech stack as the compute layer. Why do you think the compute layer is important for ASI Chain and the other kind of products and technologies within that?
I mean, if any of these technologies are going to work, they need to work at scale. And that's why the compute layer, integral compute layer on the back end, which is distributed across lots of locations if you're doing inference, is absolutely key. And you can validate where that computing is running. It's all connected on chain.
Yeah.
I think one of the things that we haven't really seen happen yet, but I really think, and I see this more and more every time a new release comes out of one of the models, is the link between smart contracts and inference.
Yeah.
And I think
you mean in an agentic workflow set?
Yeah.
Just, okay.
So basically, agents. I think agents and smart contracts are going to merge, which is part of the chain that they're working on at the moment. And I think that's one of the things that's really going to come forward, is as these agents become more and more intelligent, better at reasoning, you're not going to have to pre-build all of the smart contracts. You can create the core of the smart contract, but we're already seeing, I'm just trying to remember which company it was. It was one of the large finance companies have actually started using agents to make financial transactions.
Autonomously,
okay. Yeah, which is the first time I've seen any financial institute actually has confidence that you can potentially manipulate an agent. You can try to trick it and change its decision. It's the first time that I've seen financial institutes that they've actually got the confidence that those agents are 100% of the time going to make the right decision, which makes me think we're nearly at the point that you're going to see inference and smart contracts and agents all merging together. That actually you're just going to say, I want my smart contract to do this, and then that's it. And then and then the agents. So there's 𝗟𝗓𝗃𝗓, if you've seen in the media recently, which is something that's been a little bit spearheaded by Coinbase recently to be a micropayments method, enabling you. Initially, it's done for micropayments off websites, so you can buy data, buy information that's on a website.
Yeah.
But there's no reason why you can't use that same technology for smart contracts to be able to buy resources from each other, buy decisions from each other, use each other's resources, and the same with for smart contracts to do that via agents or agents directly. And
all of that with publicly verifiable data on chain, so you can see who transacted what, which agent has been used, and so on.
Yeah. And I think that's really going to open up micropayments and the ability for everything to integrate into each other. Because at the moment, you generally have to create bridges to connect between platforms, but
this is interesting because I think Web3 can play a very big, and blockchain can play a very big role in amplifying in this kind of agentic workflows, right? We've got Fetch, who have got their agentic stack. In fact, we're doing an Imperial College hackathon this weekend with the team at Fetch and 𝗟𝗓𝗓𝗓, just getting people to build their own agents and using Fetch technology, using 𝗟𝗓𝗓𝗓 and CUDOS technology too. And there's some blockchain elements within that too. So fascinating. So I do see Web3 and AI very much intertwined with this, where you can use the best of both for payments, transaction processing, this kind of notarization on chain that a transaction happens. So you have this immutable source of truth. That's quite fascinating. And then with the compute requirements, we're going to be announcing more soon, but we can unravel a little bit today. Obviously, as part of the ASI Alliance stack, we've got ASI Chain that's being worked on. We've got obviously the fetch technology for Agent 1, the application agent creation. We also have ASI Cloud for compute layer. We've got some ASI Create coming up. So a lot of different things will be kind of going around the main ASI chain in the middle. And we're trying to achieve is to create, integrate ASI Cloud with ASI Chain, which is kind of what you're just saying right now. We didn't have that much discussion about it before this, but we always had that plan to get closer to what ASI Chain is going to be. Yeah. And I think ASI Cloud could really play that role for anyone who wants compute at scale with some blockchain payments elements to do that via smart contracts or via this individual compute shard.
Yeah.
So that's the plan too.
Yeah, I mean, ASI Chain is built to specifically do this. You know, it is designed so that you can build the equivalent of smart contracts and how you want them to work and to integrate into agents. You know, I think it's probably going to be the leading, certainly to start with, the leading blockchain that's able to do this. It's the one that's got exactly, the one that's got the computing capacity, the one that's got the technology from a development platform, and the one that's integrated agents directly into it. It's the only one out there. So that I think is going to be
coordinated with coordinated, but using one single tech stack and token as well, because there will be token value flows between all those products. And speaking and technologies, and speaking of which, ASI Cloud, I think it's maybe worth mentioning a couple of things we've got on the roadmap. We quickly talked about this before the session. So what we're working on now is introducing, improving the way that crypto payments are done on ASI Cloud. We just want to make that a little bit more streamlined. So a lot of work is happening at the moment. What we're doing, we're adding new GPUs as well, and there will be more announcements next week from our partners at SingularityNet and what CUDOS has been doing in the deployment side. Yeah,
you probably see by some point in Q1, you will have doubled to over 10,000 sold GPUs on the platform.
Yeah, and also some big deployments coming up from the project we did with SingularityNet, Singularity Compute team specifically, which has obviously been
is also going to help power the inference services.
Exactly. Oh yeah, I forgot to. Well. Yeah, so that's why we're increasing our cluster, because we've got more hardware coming on board, and that has been a very big project. Great coordination between Singularity Compute, Singularity, and also CUDO teams, right, to get everything together. And that enables me to put more models on top. And I think there was a question just right now, hey, there will be more models. Of course, there will be. Everything we're doing is just a start. And we also, a lot of our customers have been asking for, hey, I like paying with crypto, I like mobile wallet logins, but they're also asking, hey, I've got a startup and business, I just want to use normal fiat payments. So we're adding fiat payments soon as well. So it'll be way, way easier to top up your account and get access to affordable compute and model inference. Yeah, so I think we can move to a couple of questions very quickly. Would you like to add anything before we move to questions?
No, carry on with that.
Very interesting insights. Thank you. So there's a question about NuNet. How is CUDOS related to NuNet, or are they related at all? Yeah, our friends at NuNet. So obviously we are, CUDOS is part of the ASI Alliance. And then they've got this great project that they're working on with distributed computes in devices. So we have discussions about providing some compute for them at the moment. We are related to them via the ASI Alliance work. So where we work with SingularityNet and NuNet, who are part of SingularityNet too. We're doing some work together, and we may be announcing some things in 2026.
We also set it up so that you can deploy a NuNet node directly onto CUDOS.
True, I forgot to mention that.
So we set that up this year, and that's NuNet works at the container layer. So you can go onto NuNet, you can deploy your containers across nodes that they're running, and you can also deploy it across the ASI Cloud CUDOS network.
Mm-hmm. Yeah.
So and if you want to then run a NuNet node, the template is available on ASI Cloud as well.
Yes, exactly.
So anyone can be very easily, literally it's a point and click, or do it over the...
Could you just explain what you mean by templates? Just for the audience who have never deployed GPUs.
It is a pre-built server configuration.
So you've got a GPU on the bottom.
So if you want to run a NuNet node,
you
can go onto ASI Cloud. There's a list of, they're called templates on there. It's a list of pre-built server designs that can be a base operating system. It can be, there's a whole choice of different types of use cases, and UNet is one of those. So you can choose a UNet node and to deploy. So you can run your own UNet node. And then if UNet then roll out computing, as in they've got computing demand that runs on your node, you'll then earn UNet tokens. So, so that's what we've done as the first integration.
Just to make it easy for anyone to
layer
deploy
above, and it enables them to very quickly, if they get increases in demand of container-based computing, they can then scale out on the ASI cloud network and expand on there as they need to.
Perfect.
So that's how we've done the first.
So we've already done some work with them, and there'll be additional integrations that we're looking into 2026. Of course, we've got to prioritize our features because we're so busy. We've got so many things to do. But yeah, that's a great explanation. Thank you, Matt, for sharing this. Another couple of questions. We're nearly running out of time. So someone has just asked a very interesting question. What do you think, that's the question to you, Matt, what do you think is going to happen with the AI space in the next couple of months? Are you expecting a slowdown? Is AI going to stay? And we talked about this acceleration for demand of AI compute.
Yeah.
What do you think? Where do you think we're going within the next 2-3 months and beyond?
Yeah. So we work very closely with NVIDIA. I'm in their offices every few weeks. I'm back there next week, I think it is. In the States. So that, we have a really good insight into what's happening in the industry, and it is not slowing down at all. I think where you see it in the market, people are saying there's a bubble. That I think it is definitely not a technology bubble. It might have been a temporary market bubble from a traditional stocks perspective. And then, because we had huge growth, and then
looking at the valuation,
a reduction. But if you look at S&P and the market and the technology, it continues to grow. It's growing way faster than the internet did. It's even growing faster than blockchain did. It's not slowing down at all. The technology is speeding up. Yeah. The speed of adoption is speeding up, and also its capability is speeding up, because AI is now starting to code AI. I think Claude, actually, which is Anthropic, they said that the AI now is more intelligent than the initial developer recruits that they bring into the business, and it's beating them on there. Right, so they're now using AI more and more to improve AI, which is just going to grow. There's going to be a logarithmic expansion of capacity on there. So it's like the AI explosion. You would put it this way. So it's speeding up. It's definitely not slowing down. And it's going to get integrated into more and more things. And if you think you have every 7 months, we are doubling the amount or the length of time that AI can run a single task. So that's how quickly this is expanding. And that means you need to double the amount of compute, not directly because it's getting more efficient doing different things, but the amount of compute is really speeding up. The amount of tasks it can do is really speeding up. So the traditional Moore's law is not relevant right now. It's like a different type of scaling of the Moore's law is different because that's a hardware level rule. This is really a software level rule, which is what sits on top of it. And there aren't rules in how fast you can speed up software. That's true. And also the importance of networking connection and connecting those GPUs, the setup. Like I know this for ASI Cloud, we had this, for example, our cluster DevOps team have been building the inference server, and we spent so much time on fine tuning how the GPUs are connected. When you put the model on top of that, you need to make sure the model can respond fast, the token latency is low, and those tokens can be spit out very quickly. There's a lot of nuance within that. And we've got an amazing team at SingularityNet, Singularity Compute, and CUDOS building that. And it was really, really great learning for us as well, building this kind of inferencing server from scratch using open source technologies. And the networking and all that stuff is really key to push that level, because even if you have the best hardware, you still need to be able to set it up and run it in the best possible way. Right, with this. I mean, if you look at the generations between GPT-3, 4, 5, for the model, they're saying depending on what model it is, but every 1 to 2 years, it's 10x in its capability. That's the speed that it's growing at. And we're doubling at least every year. You're doubling the size of the clusters, and then the GPUs in there are every year or so doubling the performance again, so you're just getting this compounded increase. So it just keeps growing.
And CUDO keeps building GPU infrastructure for that. Okay, that's
exactly
a good place to be in, definitely.
Well, for the next few years.
Definitely. You've been very busy. We've been very busy, obviously, at CUDO and CUDOS. That's amazing. Just one final question I've got. Someone said, and is ASI Cloud targeting Web3 AI projects to invite them to build on ASI Cloud? Yes, right, because we've got this accelerator program. We have a free credit tier where you can sign up, fill out a form. We'll give you some free inference credits. There's also technical advice. We've got a Discord community of 8,000 people right now, I think.
Yeah.
And we were shifting that community to a lot of product builders. So it's more about building products together and getting feedback from them how they use ASI Cloud.
I would say on that, which you're going to talk about soon, but capacity-wise, the ASI Cloud for the inference side is going to have a lot more capacity scaling up very soon. And that means you're going to have a lot more of the more recent higher capacity models on there that can do a lot more. So as part of your inference credits, that's where we really want to see what can people build.
Yes, exactly.
You're going to be able to build some incredible tools, some incredible ideas.
Yep.
Like business ideas, platforms, you name it, you can think it will build it because the inference is so good. And there's a lot of open source models which are close to the private models like Claude and Gemini that are out there that will be available on the network as well. So that would be really interesting to see what people can build. I think I'm excited about that.
That's why exactly getting those free credits is interesting, because when we have more models, you can build way more than that. And I think another thing I wanted to share and close with is a lot of people think, especially those who are not developers, because the audience is we've got Web3, we've got technical, non-technical audiences. A lot of people think that if you are building an app using AI, that you train your own model, or you're using your own AI. But in reality, most of the time is using those closed source APIs from the big providers like OpenAI, ChatGPT API, Anthropic. And what we're doing as part of the ASI Alliance, we're obviously building open and distributed AI systems and infrastructure too. So we're trying to encourage everyone, and this is what I've been telling to students at Imperial College last week when we had this seminar and talk about what we're doing. It's like, try to just not go for the biggest, kind of most popular things, like go and use OpenAI API. Just try open source models, and many of them are not that far behind the top proprietary models. And we are offering open source models, and with open source models, maybe quickly, can you explain what the benefits are for using your own GPU infra with your own models that you can control versus using closed source proprietary, let's say APIs?
I mean, one of them, and that was, I think, in the PR announcement anyway, so I can say it, is, we've got one provider that's just putting a big cluster on, and they're using it for confidential compute. So this is where you can run trusted execution computing, which means no one can break into what is running in that.
Could you explain trusted execution computing very quickly?
Essentially, it's just encrypted workloads. So you can run on the GPU AI. So your inference is encrypted. So the computing that it's doing, as encrypted as you can do today. So it's done at the CPU level. All of that is encrypted. And
so if I have access to the hardware, I cannot see what's being. It's just like WhatsApp end-to-end encryption. So WhatsApp can see the messages you send, but they cannot see the contents of those messages from their servers. But they know something's been said.
It's also encrypted on the chip. On the CPU chip, it's encrypted on the storage.
Right.
You've encrypted everything that you can, and then also the data is encrypted anyway, on top of that as well.
And as opposed to using, for example, OpenAI APIs, you cannot add encryption to that because they control the servers on which the model is used, correct?
Yeah, the challenge with a lot of the public platforms that are private platforms publicly available, is that they will fall under whichever rules and jurisdictions they're under. So OpenAI have to be under US rules, which can be a problem for anyone in Europe. For example, because of GDPR, your data is not allowed to go into the US.
It's true.
But OpenAI cannot say that data doesn't go to the US. Also, that data may be used for training, depending on which of the providers you're using. So if you want to be secure about your data, or if you want to provide a secure service to people, you can't do that on the public platforms.
Because you don't control.
You can't be guaranteed of it on the public platform.
Until they release their own secure inference connection,
Yeah,
whatever,
and
if they're willing to do that.
Do they want to?
Do they want to? Because data is money,
they're-
right? So
not necessarily just that data's money, but also that, you know, they are building for the masses. And if there is a smaller, you know, and they're building as quickly as they can build.
right. Okay.
So if you've got a subsection of the market that just wants encrypted workloads, it's more likely other people are going to build that, which
Right.
can be people like yourselves, you know, can build those types of services and make them available to everybody.
Yeah.
So whether you want it for your own secure AI that you want to run on there,
Yeah.
or you want to build a platform and a service that you're going to make available for everyone else to use, that's when you want to use these platforms. So that's one reason.
Yeah.
You know, and that's the encryption part. But actually, without the encryption part, it still is the security element of, you know, not having it on a platform, not having that data used for other people's training, you know, not having the risk that someone is going to access that, because there have been some public platforms, you know, they've had bugs and you can access other systems or other people's
You don't know what
accounts.
happens with your data there. Like everything you talk to those systems, it stays with someone, and they've got a timeline of all the conversations that you might have had, and you don't even have access to that. That's interesting.
And platforms like Gemini, you know, openly on their public platform, it says when you're on this, they do warn you, but it says on there that any of the staff can access your data. And that's, you know, and that's just how they.
There was already a situation with when you share a chat message with someone, there was that thing that people could see your past history of a shared link of ChatGPT, which they fixed, by the way. You can't see that anymore. That's fascinating. I think it's also worth mentioning that we have on ASI Cloud some top open source models, and there are some really good models like DeepSeek, 𝗕𝗂𝗶𝗹𝗶𝗶 that are really good. And we also have OpenAI's GPT-1 OSS 120 billion parameters. So those proprietary platforms have got open source versions of their proprietary models. So we obviously including them in the platform. So it's all about what you like to use, but we strongly encourage to play with open source models, see how you can put them on, use them, put them on the hardware directly, or just consume them via API. Just not always go for the most popular, biggest thing that everyone's using, and which obviously costs more money as well, because that costs you way more money to use those proprietary APIs versus smaller models.
The best way is to test a few of the API endpoints and different models and actually see what works best for your use case.
Exactly.
And you just use the cheapest that you can. But if you want something complex and you want something that's human level, you know, you choose one of the better models. Or if you're using it for video generation, you know, things like this. So it's not just text. You can be creating images, you can be creating NFTs, you can be, you know, building videos, you can
writing
do
code.
whatever you want on that. Yeah.
Amazing. We're on at 45 minutes. Thank you very much, Matt, for your time. It's been great. It's been great working together for a few years now. And do let us know if you have any additional questions. Our team will be sharing some more information. This stream will be available on YouTube as well after this. And we look forward to having you part of our community. Everyone, please join our Discord as well. Tune into our our X account, and also we'll be shipping out a new newsletter soon with some updates of what we've been up to. Thank you, Matt. It's been great. Hope you guys have learned a few things today, and we're going to be doing this maybe every now and then, every couple of months or month, to see how you. I know you're super busy.
Sounds
and
good.
Great. Thank you very much, everyone, and have a great day. And we look forward to building with you on ASI Cloud and CUDOS and ASI Alliance.
Look forward to seeing it.
Cheers. Bye-bye.